Okay, in your ISM, please add these notes on orbital notation. The first thing you need to know about orbital notations is that orbital notations are drawn using arrows. So we're going to be using up arrows for the positive spinning electron and down arrows for the negative spinning electrons. Let me change to my whiteboard here. Okay, so if we were going to draw the orbital notation of carbon, we need to remember a couple things. First of all, anytime I see an S on my off-bow chart, I need to draw one line over the S. If I come upon a P orbital sublevel, I'm going to put 3 lines above P. If I have a D sublevel, it has 5 orbitals, so I'm going to draw 5 lines above it. And if I go through off-bow's chart and hit some of those F sublevels, then I'm going to have 7. So there are my 7 lines for F. Okay, now, so that's what you have to memorize with orbital notations. The other thing is when you are drawing the electrons, again on these orbitals like P, D, and F that have more than one orbital, these sublevels have more than one orbital, you're going to have to put the arrow up first on each one of these lines before you can have any paired. Now you may not need all of these. Wow, that's a crazy little arrow there. I'm just learning these arrows, as you can see. Okay, just imagine those straight. But before you can pair any of those electrons up with the negative spinning electron, you have to put a positive spinning electron on each line or each orbital. Okay, so let's see if I can draw carbon correctly here. So we're using carbon, and we're going to use the atomic number to find the number of electrons. So the atomic number of carbon is 6. So I'm going to need 6 electrons, which means I need 6 of these arrows. All right, so I'm going to start on my off-bow chart. And we will use the off-bow chart, and it has 1s and a 2s and a 2p here. Let me see. Let me pull that up real quick. Here we go. All right, so here is my, I just erased it. Sorry, still learning my program here. All right, so let me go into my photo library and pull up this off-bow card. All right, now we're done with that. All right, so we're going to use the card, and again for carbon, carbon has an atomic number of 6, which means that it has 6 electrons. So it means I'm going to be drawing 6 arrows. Now some of those arrows are up and some of those arrows are going to be down. Okay, so we're always starting right here at 1s. So I'm going to write 1, which corresponds to the first energy level, and we're in sublevel S, and every time I put an S down, I'm going to draw 1 line over it, not because of the 1 for the energy level, but for the 1 because of the S, because there's only 1 orbital in sublevel S. Now I need 1 electron and 2 electrons because I'm trying to get to 6. Okay, so now I'm done with that. Now I'm getting too close to my little arrow there. I'm going to follow this path around, and then it says to do 2s. So then I write a 2s down. 2 means second energy level, sublevel S, and I'm going to put the 2 electrons there because I need a total of 6. That makes 1, 2, 3, 4 electrons total now. Alright, so now 2s is done, so I'm going to follow this path around and I'm going to go to 2p. And since it's a p, I need to draw 3 lines, 3 orbital lines, and I usually just put 2p in the center of all 3 of those. You can write 2p under each one of those lines if you want to, but that's up to you. Alright, now I have 4 electrons I need to get to 6, so that means I need 2 more electrons. So I'm going to put 1 here and 1 here. And again, we're following Hund's rule by putting those 2 arrows up. If you were to do it like this and put those 2 arrows like that, that would be wrong. Okay, so don't do that. Don't put the 2 electrons together on the same orbital because they're going to want to go on each side. So that is the orbital notation of carbon. So make sure you get that in your notes. And we're going to do potassium next. Okay, now for potassium is K. And on the periodic table, the atomic number is 19, which means I have 19 electrons. Okay, so again, I'm always starting right here at 1s. So I put 1s down. And I need those 2 electrons. Okay, then I've done with that, so I'll follow this around until I get to 2s. And 2s's can only hold 2 electrons, so there's those 2. And then it's done, and then I keep continuing. I get to 2p, and again, p's get 1, 2, 3 lines. Up arrows on each first, and then you pair down. Okay, now the maximum number of electrons in a p sublevel is 6, so that's filled. So now I'm going to 3s because the chart says go to 3. And s means there's only 1 orbital path for those 2 electrons. And for each one of those orbitals, there's only 2 electrons that can go on a line. Okay, so we're going to keep going. Now I'm going to a 3p, which means I can put 6 more electrons. If you've got more line room, just keep going out straight. I've run out of room. So 3p, I need all 3 of those electrons. And then up, and I need all 3 of these negative ones going down for a total of 6 in the 3p. So now if we count up our electrons, we're up to 18, so I still need 1 more to get to 19. So I'm going to follow 3p to the 4s. And s means 1 line, and I don't need 2 electrons in that orbital. So I am just putting 1 electron there to make my 19th electron, and this is the orbital notation of potassium. Okay, let me go back, pick this picture up again. Okay, so the next one is arsenic. So AS, and this one has a lot. So we have 33 electrons because the atomic number is 33. So again, we always start back at 1s. So I'm going to start with 1s. I need those 2. Then I follow the chart. It says to go to 2s. And I do those two. Now after 2s, where do we go? 2p. P means to draw 3 lines. And I need all 6 of those electrons there. The next one that we go to is 3s. Then after 3s, it says to go to 3p. And I need all of those electrons too. Now I'm up to 18 electrons if you're keeping track with that. And then I'm going to go to 4s. That 4 means that these electrons are going on the 4th energy level, and I need that 19th and 20th electron. And then after I go 4s, I'm going to follow this path, and then it says to go to 3d. So now I'm going back in and putting some electrons back on the 3rd energy level, and that was a D, and that means I need 5 orbital lines. And I need all 10 of those electrons. And I've run out of room, so I'm going to go down to my next line. And 3D is full with those 10 electrons. Now I keep going, and I'm going to put the last 3 in electrons needed, because we're up to 30 right now, in the 4p. So 4p, again, p means 3 orbitals, and I just need 3 electrons. And so now if you count up your arrows, you should have 33 arrows representing the 33 electrons in arsenic. Now, if I ask you how many valence electrons, you could use the periodic table, a little shortcut of looking at the column number and know that there's 5 valence electrons. Or you can look right here and right here. The highest energy level numbers that you have, the 4s, the 4p, that means that these electrons are going in the 4th energy level. So that is our valence energy level, because it's the highest principal energy level number that we have. So this has 1, 2, 3, 4, 5 valence electrons. And arsenic is in column 15. So that tells you your valence electrons. I have 2 that are in an S sublevel plus the 3 that are in the P, for a total of 5 valence electrons. And that's because they're in the highest energy level there. So the 2 electrons that are sitting here in the 1st energy level, all of these are in the 2nd. All of these electrons are in the 3rd. These 10 are in the 3rd. Those are in the 4th. Those are in the 4th. So if we were to draw a Bohr's model, we'd have 2 electrons in the 1st energy level, 6 in the P 2nd energy level, a total of 8, and we'd have 18 in the 3rd and 5 in the 4th. Okay, so that's how we draw orbital notations. You've got a worksheet to practice those. Coming up.